And one more time. All right, with that sort of stutter start, this is Dale Lutz coming to you live from our beautiful broadcast studio here in Surrey, British Columbia with my good friend, Mr. Dave Campanis. Good morning, Dave.
Good morning, Dale. Good morning, everyone.
So we're here today to talk about Raster and FME, and why don't we get going? So we've already introduced ourselves a little bit. I'm one of the co-founders here at Safe Software. I've been around for a very long time. And Dave, tell us a bit about yourself.
I worked for 15 years for a mapping company, and I became a rabid FME user, and I liked it so much I joined the company.
There you go. That's great. And so Dave has a lot of expertise with Raster, and he has played a key role in both shaping and helping us refine the Raster support in FME. And we're joined today remotely by our friend Dean Hintz. Now, he's not in Bulgaria like he used to be, but he is somewhere far away. And he's back there answering questions, so please keep him busy. And in our studio here, the studio audience actually, is Mark Stokes. Good morning, Mark. So please keep Mark and Dean busy, ask questions as we go along, and they will be pleased to answer them. And at the end, we'll kind of pick the best of the ones to recap for the whole audience, as well as have a question and answer time then as well. We'll also be giving away some seats for upcoming FME training. And I did take a look, and there is actually a Raster training coming up. Did you know that?
Actually, I didn't.
Okay, yeah, there's one coming up on the 29th of November, I think. We'll check that out a little bit more. And actually, in about 20 minutes, there's an FME desktop training starting. Did you know that, Mark? Esri.
FME for Esri.
So if you're hoping to get into that, we aren't going to give away the seats until after that is started, so it's probably going to be too late. But if some of you have to leave to go join that, we'll understand. And this is going to be available as a recording later anyway. So we always like to start by finding out a little bit about our audience. And so let me open up the polls. I know our American friends might be a little bit sick of polls. And I do think we're going to have Nate Silver helping us to decode these results at the end. So let's see, are the folks out there voting? Yes, we have, it looks like a pretty good turnout. As long as we can get more than 74% turnout, we should be okay. At least that's what Carl Rove told me. So here, oh, we got 75, so I think we're in good shape. And we're just waiting for a few of the ballots to be counted still in Florida. And looks like we're going to have to just call this election without the Florida results in. So let's share those results. And many of you, a third of you are longtime FMEers. Thanks so much for tuning in. And about 13% are brand new, and we hope that today you'll learn a few things about the product and decide and be encouraged to learn a bit more. Now, that's FME in general. In particular, we're always interested how many people are actually using FME with Raster data. So FME did not start off its life as a Raster data engine, and so that was something we added, and it took us a long time. Dave, did you know that Raster is actually quite a bit different than CAD?
Yes, very much different.
And so it took us a little while to learn that lesson. And so we took, I think we started with Raster in about FME 2006. Did you use it back then, Dave?
Yes, I started using FME in 1997.
But not the Raster?
Not the Raster. Well, some Raster, the earlier GIF writer.
Oh, right. Yes, that's right. There was a GIF writer. I wrote in a hotel room in Philadelphia, but that's another story.
Okay.
Anyway, let's take a look. And as you can see, the majority, and it is a clear majority of people haven't actually used FME with Raster data. So thanks so much for tuning in. We hope that you'll learn some stuff today and find some ways that it might help you out. Just a couple words about Safe Software. We're closing in on our 19th birthday. Been around since, I guess, 93. We make a product called FME, which is a translation and transformation tool for pretty much any kind of spatial and even non-spatial data. We don't talk a lot about that, but we probably need to. We are about 100 people here in Surrey, a few people working around the world, but we have a network of partners worldwide that help us in local markets, and around 7,000 plus customers we can't even keep track. Oh, I guess I got to do a demo already, Dave.
Away you go.
Okay, so let's see here. So I'm just going to flip over to look at some data here. So I've got this Austin data where always fans of Austin, and we're going to try to look at, this is an ECW, and I'm just bringing it up in the venerable FME viewer. That looks like a ECW to me, and I'm just taking a look to make sure that I know what I'm starting with. And the other thing I've got is some map info tab data, and so I'm going to drag this in, and we'll take a look at it on top. And so these are a number of parks within this scene. And so FME includes a viewing tool that lets us view any kind of data that we can read. And I think FME is close to 300 formats by now. All of it can be viewed in here. And what our goal is, I think I want to produce a different image for every one of these parks. Does that sound good to you, Dave?
That sounds like a great idea.
All right. So we'll start up this thing called FME Workbench, which is our tool for configuring translations. I'm just going to drag the data in there. So I had this tab file. I'm going to drag that on top of Roger's fine community answers thing. Okay, that's my tab file that I had. And I'm also going to drag in that ECW. So I'm making Workbench know about my input data. All right. And so I think we said we just wanted to clip.
Yes.
So over here is this thing we call the transformer gallery. And we can look through here to find things, or I can search this gallery for things related to clipping, for example. There's a few things there. Or if I know my way around FME, I can just go out here and start typing on the canvas. And just like that, I have a clipper. So one of the key things, if you're new to FME, is knowing what these blue things are. At the beginning, you learn by searching through here, or we have fine transformer booklets. We can see the documentation on these things if we're interested to know what it's about at any time. And anyway, this guy's a clipper. So I'm going to take, and my clippers are in fact those parks. My clippee is the image. I think I should duck in here. I do want to tell it to merge attributes. In other words, I want to bring the attributes from the clipper, which is the parks, onto the little image chips that are coming out. Because what I want to do is name the output images by their original park. Sound good to you?
Sounds great.
Yeah, you know about this one, don't you, Dave? Because I think later on you're going to refine this and do something a bit more interesting, aren't you?
Yes.
Yeah, we practiced this. For those that think we just make these things up, we don't. We actually have practiced this once before. So let's add a writer then. We can clip this, but it's no good unless we actually do something with it. I think GeoTIFF is as good as any.
GeoTIFF is a great format.
Yeah, it is kind of the classic format. And now I've got to figure out where to put that output. This is the snap demo, isn't it? So I need to go into here. Hey, there's an output directory. That's nice. We'll go into there, and that looks good. And yes, I'll add a feature type, and that's okay. And I'm just going to connect the stuff that was wholly inside or cut and inside. I'm connecting that up. Now I have to adjust this guy to say, hey, I want you to name the output based on the clipper's name, which is the name that came from the park. Now, I'm going to go ahead and run this. Let's just make sure that I'm not fooling these fine people. Is there anything in my output directory? No?
Nope.
All right, so let's run it. We write this thing, we do it, we run it. Okay, could it be done already? Wow, that was fast. I'm not used to how fast stuff runs these days. Oh, look at that, Dave.
Yeah, some pretty maps in there.
Yeah. So named after, but I noticed something a little bit funny. Why is there two named Big Walnut Creek? Do you know?
The Walnut Creek is actually split into several sections.
Oh wow, there's like a total of 5 of them, it looks like. Yes. So what's happening is that our writer was asked to produce several output images named Big Walnut Creek Preserve, or no, sorry, just Big Walnut Creek, and it added a suffix on.
Yeah, it'll just basically take the first one and give it the name, and the subsequent ones will all be numbered 1 through whatever.
Now, if I wanted to, can I control that?
You could, if you added a counter, say before the writer, to force that name to be different.
Got it. So that's a little bit of foreshadowing, but that's the end of my snap demo, and I hope you realize what did we do there? We integrated some vectors into some rasters and produced, hopefully, a useful result with really a minimum of effort, I think. So let's go back to the presentation and see what else. So what we just showed was the tool we call FME, which is our primary product. It's available on the desktop and on the server. You can put these things up to a server and have it run fairly hands-free. What I didn't show, and I'm going to just go back and show that, is that ultimately FME can be run from the command line, and you can see that here were the command line arguments. So we can change these in a batch file. As I say, these can be parameterized in a server. I can also just go in here and change the input to another set of Parks files if I felt like it. All of that is very easily done. So just a few words about Raster. This is probably the last time I'm going to show this slide set, so please pay attention, folks, because I'm never going to show it again. Just like Bill Gates said 640K would be enough, I said FME will never do Raster, but indeed, we now do Raster. So that's the last time those will ever be seen, and I'm retiring them. I haven't said we'll never do video, and you've actually done video, haven't you, Dave, with FME?
Yes, yes. With some difficulty, but yes, we can work with video.
But I'll not say we'll never do it. Yeah. So I've learned my lesson. And somebody asked, I tweeted yesterday, somebody said that I should never say we'll never do analog maps. I don't know what that means, actually, but I'm not going to say never again.
We need a Mylar transformer.
Yes. So FME is this tool that sits in the middle between all these different data types. And as you can see, raster is somewhere in this cloud, but we can integrate them, move between these data types. I can make rasters into point clouds if you want. I can rasterize point clouds if you want. I can go back and forth, use rasters as textures for 3D. All of these things are quite easily done. And the magic of it all is through FME Workbench, which is the tool for authoring these data flows. Data moves from left to right, and we get things done. We modify the data on the way through. Okay. So with that as background, we'll just go back to our polls one more time and ask you what kind of challenges you all face, especially the 60-some% of you. You can choose multiple options here. What challenges do you face with Raster? And we got some voter turnout happening. Wow, pretty evenly split across the whole spectrum of our turnout here. We'll just wait a bit longer, but we're seeing actually clipping is the surprising. No, wait a minute. Restructuring bands has fallen into the cellar here. We're going to close that with the 3/4 of you having voted. Oh, a little bit more in, and we'll share those results so you can all see. Mosaicing and tiling. Dave, what do you think about FME for mosaicing and tiling?
I think it's a great product for doing that. It makes it really easy to create mosaics from smaller images, and we can write out to a very popular compressed format like ECW or JPEG 2000.
Right. And of course, chopping into tiles, that's something it's also very, very good at too.
Yes, if you get a large compressed image and you want smaller geotips, that can be used in different varieties of software.
Yes. So, and of course, just old-fashioned bread and butter translation being good too. So let's pick through these scenarios now. We're going to go through a number of different scenarios. The first one is just translating, and I did have this fancy. I'm going to try clicking that ...
Let's go for it.
I haven't done that yet. Whoa, there it goes. And this brings us to the FME format page. And did you know you can just go here and click raster, and this shows you all of the raster formats that we do.
Wow.
And so folks at home can maybe check that out themselves, but suffice to say that there is quite a large number of different raster formats. And I'll probably leave it at that, and let's hop back to our presentation and take a look actually at a scenario that I've got from before. And if this is all right, is that here? Yeah, let's go like this. Is there one? Yeah, this is a, no, I won't see that. Here's what a translation that involves raster does, Dave. It's pretty simple.
Very simple.
I don't think I'll even bother running it, but really you just can have your input format, you connect it to an output format, and that's about all there is to it. So very easy to do translation between formats. Resampling is also very straightforward, and so let me go and grab my resampling example. Where is that? That's number 2 here. And to do that, we use this thing we call the raster resampler. And you can, I guess, say, use it in a couple ways to say the maximum size of an image you want.
Yes.
How many rows and columns.
Or you can pick a cell size if you want a fixed pixel size. Or, for some more foreshadowing, you can pick a percentage of your size.
Oh, I don't even know where that's going to show up. And I guess we also have a few different interpolation kernels you can pick as well when you're resampling.
Yeah, the least recommended for imagery would be the bicubic. It takes a little longer, but produces the best quality of output.
So I just ran this one. Let's just go ahead and inspect that output. All right. Whoops. Yeah. I got to go find my geotiff. There it is. It's a raster. That's the thing here. And if I click on it, I can see that. What will it tell me here? It's 400 by, oh, that's not surprising because that's what it was set to.
Yes, that's what we chose.
So that's a good thing. So that's resampling. Reprojecting. Dave, what can you tell us about reprojecting?
Well, reprojecting is taking an image that is captured or produced in one coordinate system and moving it to another coordinate system, which might be more useful to your users.
So to do that, for raster, we like to put down an explicit reprojector because you can get at some of these other settings then. Which this one again, and you recommend bicubic?
Bicubic for imagery. For numeric rasters, which we also do, nearest neighbor probably works better.
Okay, and so off it goes, and it'll do that. And FME supports a very large number of coordinate systems and a large number of different datum techniques. We also have some specialty coordinate system support in there for our friends in Ireland and in Switzerland and Germany. Some of these niche markets have specific algorithms that they want used, and we do have those in there as well.
Yeah, and we also have specific reprojectors for those algorithms, like the G-trans reprojector,
right.
or
G-trans, here it is.
The grid inquest reprojector.
Grid inquest. That's the one for Ireland.
Yes.
And I was lucky enough to go there earlier this year. It's a great country, Dave.
Oh, okay.
And not very big, so it doesn't need a lot of complicated shift grids for reprojection, I don't think. That's one good advantage if you're a small country.
Yes.
So anyway, that's that. We also can actually integrate the Blue Marble reprojection engine in here if you prefer to use that, and it will be used for our reprojection as well.
Yeah, as well, if you have ArcGIS installed, you can also use the Esri reprojection engine.
Right.
Using the Esri reprojector.
Right. Forgot about that. So that's reprojection. Ooh, now the mosaicing, which a large chunk of the folks were interested in. So Dave, tell us about mosaicing.
Mosaicing is essentially grouping together a series of small images to create a bigger one. Generally, when you're doing that, you would output to a highly compressed format like JPEG 2000 or ECW.
So here I have a bunch of small JPEG 2000s, and we're just bringing them together into this mosaicer. And there's a few things here. Is it worth looking at any of these? I guess this alignment section must be tell us what to do if the input images aren't quite lined up.
Exactly. If they don't fall, if the pixel corners don't fall on the same interval, which is something that's required in the final output mosaic, we have different methods of moving those or adjusting those input images so that they all fall on the same pixel boundaries.
And I think the first image in sets the pixel boundaries. Is that right?
Yes, it does.
The first one in does that. This business of no data is also interesting. No data is basically special values in cells or pixels, which means, hey, we don't know what's there.
Yeah, essentially it's an empty pixel.
Right, and so we can say if we're mosaicing and you have already put data down that has a value, and now later on comes a guy in that has no value for that area, what do we want to do?
Exactly. So if by default the no data overrides data is set to no, so if you start off with, say, a base image and you lay down a smaller image that's irregular and so has no data areas around the periphery, those no data areas will be filled in by the earlier base image.
Right. So they basically we will try our best to fill in all the holes.
Exactly.
And now I always get this wrong, Dave. Is the first image in the winner or the last image in the winner?
The first image is in the image is the Actually, the last image is the winner. It's
Right.
The analogy is if you're basically laying down photographs on a table.
Right.
So if you start with a large photograph and you lay down some more smaller photographs with holes cut in them, which would be analogous to the empty pixels, what you see on that table is essentially what you're going to see in FME.
So what you'd want to do too, if you had images of different resolution, put the most coarse resolution down first.
Exactly.
And then the finest ones last, and that should give you the best result. How do you control that? Well, in FME, we can do this thing called sorting. And so we can go and use a sorter, which could sort stuff ahead of going into the mosaicer. So we could sort by pixel size, for example,
yep,
and sort it in descending order. So the biggest guy comes in first, and that would give the best result.
Exactly.
So that's just some things about mosaicing. I don't know if there's too much else. There's other options in here about merging palettes. That's to do with images that have color tables.
Exactly. Not so much used in these days, but in the old days to save space in a file, and the GIF files
Yes.
are a good example of this, is that they would have a palette of 256 colors. And so you would only need an 8-bit image to store what would normally be stored in a 24-bit image.
Right.
Actually, paletted images work really well if you're coming from vector line work. Say if you're rendering out a map, because usually there's a limited number of colors.
Yes. We have a bunch of operations in FME around palettes. One worth pointing out to folks is that there is a palette generator in here as well that will go ahead and basically create you a palette.
Yeah.
Giving it its best shot. And you can also say, hey, look, I want to limit the palette to, say, well, at most, or at least 16. I can say 20 or whatever, and it'll jam the colors down to that. But that's a bit of an advanced bit of functionality as well.
Yes, it is.
We're not showing that today, actually.
No, we're not.
Okay, quick, I'll get rid of it. So anyway, that's mosaicing, very powerful, widely used, and I was pleased to see how many folks out there want to use it. It's, as you saw too, the workspaces are very simple. Just drag everything, connect it into the mosaicer, and one thing comes out. So that's pretty straightforward, and possibly sort stuff ahead of time if you care about order. All right. Compression. Well, compression isn't a blue operation. It is instead, let me just go and get the one here with compression. Compress after mosaic. So this one was going to GeoTIFF. If we wanted to compress, this is actually showing off. I'm also reprojecting here after mosaicing. And then I was going to ECW. And that compression does take a little while. I think this one here, this is a pretty big one. I think I ran it last night. It took about 2 minutes. So let me just show you the result of looking at that thing. There it is. So this is an ECW. That's, how big is it? Well, 10,000 by 10,000 approximately. And I don't know, Dave, are there parameters that can control the amount of compression?
You can set the compression ratio.
Oh, there it is.
Yeah.
So to do that again in slow motion, I right-clicked on the output. I said properties. Actually, I didn't. I actually just hit the ... And then it brings me up the properties. And then at the far right, there's the format parameters, and that's where I can put the percentage in. This is a fair, what's an aggressive percentage?
An aggressive percentage would be anything higher than 80.
Okay.
I think after that, you're starting to see a little bit of degradation in the image.
Right.
But the default 75 will give you an image with almost no visible degradation.
Right. So that's ECW. Similarly, we can do it for JPEG 2000 as well.
Yes.
We cannot write Mr. Sid. Our Lizard Tech friends won't let us do that, but we can read it.
Yes, we can.
So so you can go Mr. Sid to ECW if you wanted to.
Yes.
Not that we're encouraging that, but can be done. So here's some of the other formats that have compression in them. Clipping we already saw, so I think I'm just going to skip right over that. I don't think that there's any need to show a demo of that.
The only thing I would add is that if you have multiple clippers, you have, I think, the option of merging the output into a single raster or multiple rasters.
Right. Oh, and that's what we had going on. So I did bring it up after all. This was an example that was looking at, I'm just going to run it while we're talking, reading some GML. We always like to show GML during any of our webinars. So this was GML being read for some zoning polygons. And we're reading a Mr. Sid. Oh, we are reading a Mr. Sid.
Yes, we are.
And now we're pulling out of the zones, only the zones with SF3 as their type, 394 of those zones were red. We put them into this aggregator. What did that do, Dave, the aggregator there?
The aggregator basically takes all of the clipping boundaries and makes it into a single feature. It's an easy way to create a single clipping boundary of multiple polygons.
Okay, it's a multi-part feature. And so one clipper comes in, which means only one thing comes back out.
Yes.
All right, and so if we, let's take a look at the containing folder for this thing. And, okay, come on. Oh, let's see if Microsoft can show us the preview. It must be pretty big. Yeah, there it is. So that's what that looks like, that image after we're done clipping it. So just one image came out and it was all clipped like that. Okay, that's clipping. So what else do we do here? Oh, a combo scenario. Mosaic, reproject, clip, and catalog.
Yes.
Okay, okay, Dave, what is this one all about?
This one is basically, we wanted to create something similar to what we did in our first example, but we wanted to put it into a more user-friendly format. So it creates a HTML catalog of all the park images.
Okay, so well, it looks like we also had a bunch of tiles. This time it was a tiled input as well.
Yes, yes. We took the Mr. Sid tiles of the area, we mosaic them together in the master mosaicer, and then we do a little something different. If you recall the first images, after clipping, the background was all black.
Yes.
And we don't really want that in an HTML page because the page is white, and it would look kind of jarring. So if we open up the raster band no data setter, that's quite a mouthful.
Okay.
All I've done is I've set the no data value to 255.
Okay.
Now it sets that no data value on each band, so it's essentially creating a no data of 255, 255, 255, which is white.
Okay.
So we don't actually have any no data right now, but as soon as we clip, we will, and it will set that no data area to a white background.
So okay, you're setting that up so that when you clip, the areas that aren't square, or the little pieces that have to fill in to make a square, will be white.
Yes.
Got it. Okay.
Okay, next step is the clipper to clip out the parks as we did before.
Yeah.
Now, because we're creating an HTML page, we need to know in advance what the name of those output files are going to be. And as we saw with the first example, for the big part that's in multiple pieces, the writer will automatically number these pieces, but we don't know in advance what they are. So what we're going to do is essentially put in a counter, and we're going to get ahead of that process.
Right.
So a counter, we're going to give it a count by the park name. So the counter can have multiple counters that you can assign to an attribute, and it will keep multiple counts as it.
So Walnut Creek will get, the first Walnut Creek will get a value of 0, then it'll get 1, 2, 3, and then when George Jefferson Park comes in, it'll start
reset
back
to 0 again.
Got it. Okay.
And all the counters are independent of each other.
Yes.
So now that we know that count, we concatenate that value into the name to create an output name.
So it's an underscore and then whatever. So we'll see like George Jefferson underscore 0.
Exactly.
Right.
So now we split the streams. Oh, yeah, exciting. The first stream up at the top is creating the actual images files themselves. So we send it into a raster sampler. Now, in this raster sampler, because I'm creating sort of thumbnail images, but I wanted to keep the proportions of the images usable, so you can see the proportional sizes.
So like George Jefferson Park might be very small as opposed to Walnut Creek, which is huge.
Exactly. So I just gave it a blanket reduction to 10% of the original size.
Okay.
And again, I set the interpolation type to bicubic.
Right.
So the next step is to force the input image to RGB24.
Okay.
We do this because we're going out to JPEG, and JPEG essentially only accepts monochrome and RGB24. So if our input data has a different type of color space, we have to force that that into the correct color space before we write.
So what was the color space flowing through here? Would you make a guess? It was coming from Mr. Sid, and
it would probably be RGB24.
Okay, so this is just making sure.
This is a belt and suspenders thing.
Okay, all right.
So
that's fine. And then there goes our JPEG, and it's fanning out by that image name thing.
Yeah.
Okay.
And actually on JPEG as well, if you open up the properties, you can also set the compression percentage there as well.
Well, you did an oddly chosen 28.
Yeah, I think that's the default as well.
Okay. 28. All right.
It's a light compression that won't degrade the image.
Okay. Okay.
Now,
so that's okay. Now, for folks that don't know, whenever we split the streams like this, basically one copy of the image went up and another copy went down. We doubled down here.
yes.
And so now on the down part, what's going on at the bottom?
Well, now as part of the catalog, we wanted to put in a little bit of information about the park as well as just the picture. So I decided to put in the bounds of the park, but to do that, we want a sort of useful bounds that everyone will understand. Now, the source data is in Texas state plane feet,
Yes.
which would basically give a bunch of big numbers that nobody knows what to do with. So I'm reprojecting here to lat long 84, which will give me decimal degrees.
So you're messing with Texas.
Yes.
Okay.
I'm bringing Texas back into the world.
Okay. Okay.
And now everybody understands latitude and longitude, so you've got a good understanding of what these numbers mean.
And so really, you're doing that just to get new bounds.
Just to get the bounds of the park. Yes.
Now, for people that don't know, this might seem like a lot of work to go through to just get the bounds. But I need to explain to the folks at home that FME is inherently lazy. And so when we put a reprojection on the image, it doesn't actually do any work on the image right then. It just says, well, in case anybody ever asks me, I will do the work to know where the pixels are. So this actually takes no time at all to do this. It isn't actually doing the work. And when Dave asks for the bounds, this thing says, well, okay, if I was reprojected, what would my bounds be? And it gives it to him, and it still didn't really do any work. So this is very, very fast to do.
Yeah. FME's raster processing works on a pull model, in that we look at the output required before we actually read the input.
Yes.
And we take the processing steps along the way, and we bundle them all up into a single transformation, and then basically run the data through backwards.
Yes, it's like, I've heard that it's like an onion skin, which is also like, I think, ogres from Shrek. You start on the outside, you have to peel it off to get to the inside. There's somehow a Shrek tie in there, but really the original file is at the inside of the onion, and then as you layer reprojection of the things on there, we just layer that all on. We don't do anything until at the very end when you go to a writer. That's when we take the great big bite and do the work.
Yeah, there's two big advantages to this this method. The first big advantage is performance. We only read the pixels we need. So if you're taking a small clipped area out of
Yes.
a very large, say, ECW, we will only read the section of the ECW that's required for the small clipped area. And this makes the processing much faster than it would be if we had to sort of read the entire data, source data ahead of time. The other advantage is that whenever you do processing on a raster feature, each individual process slightly degrades the image.
Right.
As part of the processing. By bundling all our processes into a single transformation under the hood, essentially we're minimizing the amount of image degradation. So you can tie together a whole bunch of manipulations and be confident that you are not overly degrading the image the way you would if you did them all separately.
Right. So anyway, I think we'll just sort of skip through the rest of this is basically building up some HTML.
Yes.
Is that fair to say?
Yeah.
And then we get to see it. And for those that are interested, we're going to make all this stuff available with the data and everything else, and you can try this at home yourselves. So I'm going to just go ahead and take a look at this output, Dave. Let's see, and you can try this too if you're at home and take a look. And here's the results.
Yes. Simple but pretty.
So is George Jefferson Park actually in here? I just made that up. I don't think.
I don't know.
I don't think George Jefferson has a park. But anyway.
The Big Walnut has many parks.
Yes. So there they are, and there's the various pieces of Big Walnut Creek, and these all would have different file names that were generated for them. So that's the combo. Okay, tiling. Some folks said they were interested in tiling. Let's see what I got for that. Create. Nope, not okay. It would be this one. Save changes. No. Let's look at tiling's pretty easy because really it's just a thing called the raster tiler. What is there to say, Dave?
The raster tiler allows you to choose either the number of tiles or the tile size.
Yeah.
And it gives you different options for each. At the bottom, it puts several attributes on the feature, mostly which is the column and row of the tile, so you can keep track of them afterwards.
And here we typically we use a concatenator to glue together tile, like some kind of naming scheme. So this goes tile and then the row underscore column puts it in file name. And then on this thing, we must be fanning out by file name. And I did run this last night. It's a little bit big to run right now. Let's open the containing folder. And there you go. These are the various tiles that came out.
We've tiled that ECW up in 4 pieces.
Yes. Okay. So that's tiling. So that's pretty straightforward. Web tiling. So let's take a look at what that is. And oops, yeah. Okay. Web tiling. Web map tiles. Here we go. So basically, we're reading in a bunch of geotips in this example, and we're producing a bunch of tiles with the web map tiler. And what are these things for, Dave?
This is for essentially creating an image tile cache if you're doing some sort of image server on the web.
Yeah.
So just sort of running through the steps there, one of the key things to do when you're doing this sort of operation is, again, I'm using the raster interpretation coercer up front, and I'm forcing it from essentially RGB24 to RGBA32. So I'm adding an alpha channel in there.
Yes.
And this is very important for web map tiling. So now our source data doesn't really have any empty pixels to begin with, but as part of the web map tiling and the reprojecting we're going to do, empty pixels will be created in some of these images.
Yes.
So all of our operations that create empty pixels, if you have an alpha channel, we'll set that alpha to 0. So make sure that they're transparent.
Got it. And that's why, because here, before you did that, you had to get into this fancy spherical Mercator, which is the chosen thing for
all web map tiles, Bing, Google, and OS.
Yeah.
OSM, yeah.
And so that's the thing here. Now I'll just deviate. I started up FME 2013 because in the FME 2013 we've got a new web map tiler, and we'll talk more about FME 2013 later. And have you seen this yet, Dave?
No, it's something new.
So you basically can choose some different schemes here because OGC has a spec, and so we have included their scheme as well as the others. So that's something that I wanted to make sure folks were aware of.
Yeah, we should also talk about in that web map tiler the zoom levels.
Oh, right.
There are settings for zoom levels in there, a minimum zoom level and a maximum zoom level. Now, if you leave those blank, which most people will, FME will sort of calculate the optimum parameters so we won't produce empty images if the data doesn't fit the zoom levels. We also won't zoom in past the raw resolution of the image.
So you can see I've got a web page there that we must have. Oh, there it comes in. There we are at higher resolution, slowly coming in.
Yeah.
You can see it. All of that is the data that is produced by this example. I don't know if auditory is it going to come in. Doesn't look like it. So that must be in tighter than what my zoom levels are now.
Yeah. So there's no tiles
there
at that zoom level.
Right. So that sounds good. So let's flip back to carry on. Draping. Well, there's not anything as much fun as draping. Let me get rid of FME 2013 here, and I'll go back and let's see, simple drape.
Yes.
Well, it doesn't look as simple as I'd have liked, but it's got a few things going on here. Oh, we got shape files that we're using to clip our data, I guess, and make a 3D PDF. So we've somehow, oh, I see. We've got, oh, I see. The shape files are being used to make the surface model.
Generate the surface, yeah. So the shape file, the contours are generalized to get rid of the noise in them to make a smoother image. They are forced into 3D based on the elevation attribute.
Yeah.
Then they're sent to the tin generator, which takes the new 3D lines and creates a tin surface out of that. From that surface, we create a clipping boundary for the input image.
Yeah.
Because at present, to assign an image as an appearance to a surface or a texture on a surface, they both have to be exactly the same size.
Got it. So
we're working on that for 2013.
Yeah.
But currently in 2012, they do have to be the same size.
So then we get this fine bit of image here.
Yeah.
You know, really, Dave, you and I should go there to make sure that this lines up.
I packed already.
Okay, good. So anyway, that's a 3D PDF, and yes, Virginia FME can make 3D PDFs. And they're very impressive, and we always say that even our parents can use these.
Yes.
So there we go. I won't save any changes. So that's that one, and I think we have another example. Whoops. Yeah, back on the draping side. There's a more complicated example that we'll send all to you. And let me just look here. This one here, I'll just quickly talk through. It brings a bunch of different input together. So we've got a raster image, we've got vectors, and we use something in here called the vector on raster overlayer, which basically draws rasters, draws vectors into rasters, burns them in.
Yes.
And then I think we even have a 3D model here too. And I think actually is this Mark Ireland's house in Manitoba? Do you know?
I don't know.
So this is all the inputs there, and the result is this thing we call Uberdrape.
Very nice pronunciation.
I did take German for 3 years in high school. So all I can do is say Uber and geschlossen. That's another good word to know. It means things are closed. Anyway, and so we can see the terrain there, and that I think is Mark Ireland's house in Manitoba, the FME evangelist.
Wow.
So anyway, there we go. So that just shows you, again, integrating some stuff with raster, and off we go. On the power side, we can do things like expression evaluation per cell. There's a lot of very powerful parts of it, but we don't have time to really dig into all of the higher end things today. I suppose if you took the raster training in a couple weeks' time, they'd get into some of these things.
Yeah, they would. And the expression evaluator is kind of meant to be a sort of core transformer that we will build simpler to use transformers that sort of utilize its power in the future.
Yes. And let me just see here to give you an idea. This is, there's a very long list of raster transformers, most of which have the word raster in their name. So that's kind of handy. But things to make pyramids and rotate and all kinds of things like that. So just taking that, look at this example here where we're taking a numeric raster, so an elevation model, and we're going to make ourselves vector polygons. And I think now I'm ready, Dave, to start using FME 20. Whoa, I got lots of stuff here to clean up. Let's clean up my mess, and I'll just fire up FME 2013 here because I wanted to show a couple of things from that. So, and in here, if I look, I should have my recents, and I want, no, I'm not doing conflation. It must be segmented raster. There we go. So this one here is going to do that segmentation, and this is using the expression evaluator, and I can go and write expressions here that are going to create new bands. And so this one is just creating one output band that is the result of dividing by 25, adding half, and multiplying by 25. I'm rounding it to the nearest 25.
Essentially, yes.
Yes. But I can do all kinds of other operations inside of here, if, then, else, and things on multiple bands and so on. And then I basically use this guy, which draws polygons for all of them. I use some powerful map generalization to fit NURBs. So we get rid of the staircases from the polygons, and I fit NURBs. And I'm going to go ahead and run this thing just to see it go here. And then at the end, I just output it all into a nice output file in the viewer here. So let's just take a little looky and turn on all the data. Original elevations, whoops, the original raster is here. Then this is the output. So if I just drag into here, you can see that they're all somewhat nice and curvy, better than a staircase. And if I click on this guy, with luck, I find out that it's at 225. So if I go to this side, it's going to be 25 one way or the other. Better not be not that. So here we go on this guy, and it's going to be, it was.
Yes.
So I'm happy to see that. So that's that example of raster segmentation. And so now we have also all these niche formats that we can do. And I thought, again, a little bit more a sneak peek from FME 2013, our new icon there, which we're not really allowed to show yet. But he says, go ahead, make my data. And we have hill shading. And so let's see if I can dial up that one. Open recent, something about hill shading. There it is, raster hill shader. So it's a hill shader.
Yes, it is.
And I don't know what these things mean, but
well, the azimuth is the bearing of the sun from your location, and the altitude is the altitude of the sun in degrees above the horizon.
Right. Okay.
So
and then it looks like we've got some algorithms, which I have no idea what they are, but the documentation would tell you.
I hope so.
So we'll blow our own horn here and run this. And you should see, whoa, okay, there it's done, and so the elevations will turn off, and that's the shading.
Yes, very nice.
So yeah, it looks cool. I think I did some of this sort of stuff using punch cards when I was in university. That exact thing took us a whole month, what we just did in a few seconds there. But anyway, it's kind of fun to see that coming. And so to that end, we want to ask all of you at home, you've seen some of this stuff. Hopefully you've got an idea of the breadth of what we can do today, the integrations, the seriousness with which we treat Raster, our support for different bands and data types and all those sorts of things. So now we want to ask you, as we're planning our FME 2014 work, the work we're going to do for the next year, what kind of stuff could you imagine using if we were to add it into FME? So we got the poll open, I believe. So on the first one, you may have heard of Mapnik or the tile mill guys. We're looking at integrating that, which would let you run vectors in, and we could make really beautiful cartographic rasters by tying into the tile mill stuff. Would you use that, Dave?
Yeah, in some cases I would.
Yeah. So better convolution kernels for resampling, smoothing, image processing. We had to be a little bit hip with our things there because we're out of space for the poll question. So that's something that I can imagine people using. Rubber sheeting or georeferencing with ground control points. And then your basic image processing, the things that I suppose free tools have done for a long time. That would mostly make sense on color or black and white images, not so much numeric, I would think. Would it? Or would you do it on numeric too?
Actually, I would do it on numeric if I was, say, calculating slopes.
Okay, yes.
Because generally you want the general slope, and we use a tin process, which can create some very sharp local slopes that really don't reflect the character of the ground.
Yes.
So generally, if you could put a blur on the raster DM before you created the surface, you'd get a more sort of representative slope of the area.
Right. Okay, well, we'll stop there and we'll just share the results for folks to see. So it looks like the rubber sheeting is something that that was the clear favorite, followed by Mapnik, which was my sort of pet project that I've been wanting to do for 2 years, and so that's good to see. And convolution kernels pulling up the rear. So, well, the crowd has voted.
Yes, they have.
Okay. Thank you so much. That is very, very helpful and does help us as we anticipate our next work. Dave, you know what? We're actually going to finish on time.
Wow, I think that's unprecedented.
Yeah, well, we didn't have microphones cutting in and out or any of those sorts of fun technical problems this time. So far, yeah, I guess I better not jinx us. So in case you want to replay every second of this and hear it again, or maybe share it with your friends, we have recorded this webinar. We're also beginning to do kind of a post-process where we chop bits and pieces out. Did you know we do that, Dave?
I did not.
And post them on YouTube. So if you want to hear Dave say resample, we'll be able to have that little section out by itself, or me going on about George Jefferson. That'll be pulled out and be able to be viewed in more bite-sized little pieces.
Let's go viral.
Yes. Okay, and so if you are new to FME, you can certainly help yourself to a free trial off our website. We do other weekly webinars. I know Mark Stokes would love to give you a personal web demo, wouldn't you, Mark?
Absolutely. I'm doing one this morning.
Okay, well, while he's in here answering questions, he's actually doing one. Seriously, though, we do have other webinars coming up. I know that a lot of us are looking forward to this. It's a multinational webinar on improving performance in FME workspaces. So tricks like what Dave was saying about the raster, understanding what's going on inside FME to maximize performance. We got Ken Bragg, SAFE staffer working out of France. I think we got someone from David Eagle, a longtime FMEer out of the UK. He's got some great tips. And I might even chime in on a couple of things myself. Did you know anything about that one, Dave?
No, I didn't, but I am interested now.
Yeah, so it should be fun. And sometime in January, we're going to be doing a webinar to introduce FME 2013 in all of its glory. And we can take a quick peek at the upcoming training by clicking there. And if I roll down here, the things that are done by SAFE, there is an advanced raster one on the 29th. So, and that would put you out $500 unless you were lucky enough to win. So let's see. We should have a poll here about winning. There it is. Let's do that poll. If you're interested in that training. Oh, we look at that. They've upped the number of seats to 25. I thought there was going to be 10.
Whoa.
So if any of you are interested in tuning in on the 29th, Mark, do you know who's teaching that one?
Which one?
The advanced raster in a couple of weeks?
I don't actually at this time, no.
Okay, so it's a mystery instructor.
Mystery instructor.
So that's even more. I'm curious now. I might even tune in to see. Are you the teacher, Dave?
I don't believe I am.
Okay, well, it won't be Dave then, but some lucky safer will be the instructor, and that'll let you really dig in and get to the bottom of many of the things that we saw today.
Oh, Dean is the instructor, he says.
Okay, the silent Dean. Who's, will he be teaching it from home or from Bulgaria, or will he come into here? Do you know? We don't know. He might be in parts unknown, but he will do a fine job. Dean actually has a very long background in raster. He worked with a company called Facet. They had another name, but anyway, it was basically, the idea was that you make rasters in spreadsheets. And that was from MDA, where Don and I used to work, and the original product was called Why Not? Rasters in spreadsheets, why not? And that was the name of the product, Why Not? So just to wrap up, hopefully today you've seen a variety of ways that you can use FME to prepare and share raster data quickly. And I hope you've seen how quick these things can be set up. And really, I think raster is pretty fun in FME.
It's great fun.
Yeah, it is. And we have a lot of pride in our raster support. It was a hard battle to get it to the point it is now. FME 2013 actually beefs up performance in a number of areas on the raster. I didn't mention PostGIS 2.0 raster. Actually, today is Post-GIS Day. Did you know that, Dave? Yesterday was GIS Day. Today is Post-GIS Day. It's the day after GIS Day. It's also the day we celebrate PostGIS. And for that, I can announce to these fine raster people that FME 2013 supports PostGIS raster.
Yay!
And that's a little gift for you for Post-GIS Day. So Mark, in the last few minutes we've got here, are there any noteworthy questions and or answers that you'd like to shout out to the audience?
There are a few questions. The background color when clipping, can we change that?
Yes, we can. We can change between black and white.
Sort of, yeah. So you can have any color you want as long as it's black or white.
Well, no, actually, you can use other colors. Generally, because we're setting it on all bands, we're setting it by band and all bands at once. You essentially get a whole bunch of shades of gray. But we have a lot of nifty other raster transformers, like the raster selectors, so that you could select the red band, set a value, select the green band, set a value, select the blue band and set a value, and then get a customized, say, chartreuse color as your background.
Transparency?
Transparency we can deal with by moving it to an RGBA image that supports an alpha channel, and then you can actually, there's different ways of setting the transparency on that alpha.
So what if you crank it to RGBA before clipping? Then you should have an alpha channel there. Is there some way afterwards to fiddle with the alpha channel to set a color there? You know?
You might have to revert back to the no data setter.
Okay. Okay.
And manipulate that channel, or just do a straight. I believe we have a cell value replacer where you would again select that channel, replace the cell value of 0 with a different transparency value.
So I think the short answer is it can be done, but it's a little bit tricky.
So anybody having problems with that can send a note to safe.com/support, and Dave will...
Actually, this sounds like a good FMEpedia article someday, or an FME Answers kind of thing.
And then there were a few concerns about what kind of size of raster we can support in terms of mosaicing and also reading in rasters. And
we can support some very large rasters. Our memory handling is fairly good. It's not always perfect, and you may run out of memory on certain operations. However, we also have a 64-bit version of FME, and if you're doing any serious raster processing with big images, definitely have a look at our 64-bit product, and there you're limited. Your memory limitation is based on your bank account.
Right. So, and as Dave said, over the years we've done a lot of work to be better and better with memory usage. You also need a lot of temporary disk space for some of those things.
Not so much. One announcement for 2013 is that the temporary disk space requirements for creating ECW files, which were considerable previously, are now no longer required.
Well, there you go. I didn't even know that. I'm gonna have to get you to be part of the FME 2013 announcements, Dave.
Okie dokie.
No, that's I know people used to complain about running out of temp disk space, and
Yeah.
so we basically removed that problem.
Yeah. Our boffins in the Raster department have been working overtime on that.
Well, they're good boffins. A lot of people don't know, but our primary Raster developer is also, I would argue, a world champion Tetris player. He was at a conference 2 years in a row and beat out 60,000 other people in Tetris. So that's pretty close to world champion in my opinion.
Yeah, well, it's all pixels.
Yes, exactly. And so that's the kind of guy I want programming my Raster support, is the guy who's a Tetris champ. Anything else?
So I think that's it.
So we're out of stuff to talk about. Is this really true that we're done with 2 minutes left to go?
Yep.
Well,
that's it. Everybody get on.
Carry on now. I feel like Ferris Bueller, go away. We're done. So anyway, seriously, folks, thanks so much for tuning in today and for spending time with us. We've had a lot of fun prepping this talk. We've had a lot of fun evolving and experimenting and refining the Raster support in FME. As always, we welcome your input. Please tell us what things we can do better, what things we're missing that would be helpful to you, and tell us what things we're doing that you like, because that helps us as well. And we really appreciate your feedback on those different areas. We are just planning our FME 2014 work now, and I know that will help us as we figure out what to do next. So from foggy Surrey, British Columbia, this is Dale Lutz
And Dave Campanis,
And Mark Stokes.
saying goodbye.
goodbye.
And thanks for all the fish.